Good morning, everybody. We are back with another lesson. This time we were looking at solving inequalities by adding and subtracting. This is a very tougher topic, I would say. So I would suggest to go back and look at solving equations first. One of the biggest differences here is that we're going to actually graph our results. We are going to do a couple problems, so this might be a longer video. And as always, I'm going to try and take a real-world application approach to this at the end. So I hope it's helpful for you. Please leave a comment. And as always, liking or subscribing to the channel will definitely help me out. Thank you. All right, let's take a look at our first problem here. So the goal here is that we obviously want to get our variable by itself, just like we did with solving equations. So what I find to be difficult when introducing this to kids is that they're thrown off by this, right? This is exactly the same thing, more or less, that we did when we're solving if there was an equal sign there. All right, so we're going to treat it the same exact way. All right, so what we need to do is combine our like terms, which are right here on the side with J. So the signs are different. We're going to subtract, so we're left with J. 20 minus 14 is 6. Since the 20 is larger, it's positive 6. Okay, now what we're going to do is we got to get rid of this 6. All right, and I'm going to say this now, but I'll repeat it multiple times, is that we want our variable on the left. All right, so we talked about this with inequalities in a previous lesson entitled Inequalities. You want to have your variable on the left for graphing purposes. So it's already on the left right now. We can do that at the beginning or the end, but we're in a good spot right now because it's already on the left. So our final inequality is that J is greater than 19. So what I suggest to kids is that, as long as we know that it's on the right of the 0, we have 19. Now in previous videos, I graphed it right on the number line. I want to do it above, just for those that have it above. It's an open circle, remember, because there's no line underneath this. If there was a line underneath, it would be a closed circle. And once again, look at this inequality sign here as if it's an arrowhead pointing to the right. So it's going to get shaded to the right. All right, let's take a look at another problem. What we want to do first is get rid of those parentheses. So we see here that we can think of keep, change, change. So we have x plus plus, or plus positive. So now it just simply can be written as x plus 13 plus 18. Now you can probably tell already that you're going to want to combine like terms, but let's do it one step at a time. So on the right side of this inequality sign, same thing, plus the opposite, which is now positive, 8 and 9. All right, so like terms here, like terms here. All right, x plus, now signs are the same, so we combine them, 31. 8 plus 9, that's 17. All right, so now what we're going to do is just as if it was solving an equation, we're going to subtract 31. So this would be where our river is, if you remember me doing that in other videos. All right, minus 31 on this side. So x is less than or equal to, well, the signs are different. Remember, this is a positive 17. So you subtract 14, and it's negative because this is the larger number. Now, when we go to graph this, we want to make sure that this variable is on the left, which it is. So we're in good shape. Negative 14. All right, so we put a circle on top. Well, we notice that this has a line underneath, so we close it. And it's pointing, our inequality is pointing to the left. So we're going to shade it that way. All right, now some teachers require you to put a number before it and a number after it, so just be careful with that. All right, let's take a look at this one here. This is definitely a whopper of a problem. You can see that we got some decimals in here, no big deal. All right. Also notice that our variable is now on the right-hand side, which we're going to fix at the end, okay? Because remember, in order for us to graph correctly, we need our variable on the left, which we'll get to. All right, so we do have some like terms here, like terms here. All right, we're not combining them all at once, right? This separates in the middle here, separates what we're going to combine first. So we have the 1.3 and the 3.7, which actually is nice. It works out to be a whole number of 5, all right? The s will not be messed with yet. And then we have the 6.2 minus the 5.9, right? Which ends up giving us a positive, because we are going to subtract, a positive 0.3. Okay, now we want to get this s by itself, so we're going to subtract the 0.3. All right, we subtract the 0.3 here. Remember your rules of decimals, right? When you're adding or subtracting, the decimals have to line up. So after we do so, we got 4.7, which is positive, is less than or equal to s. All right, now, as I said before multiple times, we want to have this variable on the left in order for us to graph correctly. So what I suggest is switch these. If we look, this is originally pointing at the 4.7. So when we switch, it should point at the 4.7. Now we're good to go and to graph. So it's a positive 4.7, which means it'll be on the right side. This indicates that it's going to be a closed circle. Arrowhead is pointing to the right, so we shade to the right. All right, here we go. This is a perfect example of inequalities and how it's used in real life. So to all the haters out there that say you never use algebra in real life, here you go. Because we do this with school, because we actually do take a trip to a Broadway play. All right, so it says that total, let's read through it here. 9 members of the drama club are going to New York to see a Broadway play. There's 9 people. The total cost for the tickets, which includes a $15 fee, will be no more than $285. What's the max cost? All right, a lot going on at once here. Well, we know that no matter what, we're not paying more than $285. So no more than, which you can go back to our inequalities when we talked about the phrasing of inequalities. That means, yeah, we could pay less than that, but we also could pay exactly $285. All right? 9 members. So 9 members, each are getting a ticket, right? So 9 times whatever the ticket price is, which ultimately is what we're trying to figure out. All right? This also includes the $15 fee. All right, so which we'll eventually take away from this. All right, so as we go through it, we have everything we need now, right? So these are our people. This is the tickets, which we're trying to figure out. So we're going to subtract 15 from both sides. All right, we subtract 15. All right, and remember, since it's talking about prices and money, there is a possibility that we could get a decimal. But as we go through it here, we can see, we're going to divide. We can see that we're probably not going to get a decimal. All right, so the price, max price, would be $30. So this is a good example, because like if you guys are putting a trip together or whatever, like, well, what's the most that we're going to have to pay? Because that might determine whether or not someone's actually going to go on the trip. All right? Okay, everyone, that concludes our lesson on solving inequalities with addition and subtraction. Obviously, the next one will most likely be multiplication and division. You'll see that it's more or less the same process, except there's one little tricky part that we have to remember that makes it a little bit difficult when it comes to the graphing portion. So I hope it helped you out. I hope it's useful. If not, or if it did, make sure that you leave a comment. And you know, I'm trying to make this channel so that the audience or the students kind of guide where I go. So if there's something that you want to you haven't seen yet that you want to see, make sure you leave a comment and let me know. Thanks.